Today on How It's Made Dream Cars, the McLaren 650S, a supercar for the racetrack or the open road. Famed New Zealand driver Bruce McLaren won his first race in the Austin 7 Ulster. He founded Bruce McLaren Racing in 1963. The team competed and won in the Formula One, Can-Am, Indy 500, and Le Mans races. Today, McLaren cars are legendary for their extraordinary performance. In 1992, the car maker unveiled the McLaren F1, a road car that rewrote the supercar rulebook. With the F1, McLaren distilled its unparalleled success on the track into the fastest naturally aspirated production car in the world. The 650S continues the tradition. It is a series production supercar, available as a coupe or convertible. The car's twin-turbo V8 is the powerhouse behind a blistering acceleration pace. It has a top speed of 207 miles per hour and can go from 0 to 60 in just 3 seconds. Back in 1981, McLaren pioneered the use of carbon fiber in Formula One. And in 1992, the McLaren F1 became the world's first carbon fiber road car. The 650S is no exception. It's fitted with a lightweight carbon fiber monocell chassis with aluminum crash structures bolted to the front and rear. The McLaren Production Center is located next door to the McLaren Technology Center in Surrey, England. At this station, a technician assembles the front and rear crash structures onto the carbon fiber monocell. A specialized fixture helps him manually guide the structures into place. He uses a wrench with a preset torque specification to tighten the bolts. Like many supercars, the 650S is hand-built. Even though there are no conveyor belts or robots in this facility, McLaren still manages to construct 8 cars a day. The technician marks each bolt to note that it's been tightened to the correct torque. A 2-part high-strength structural adhesive is applied to large parts of the body structure, like this windshield frame. The technicians clamp the part in place with the help of precision set pins and mylars. These positioning tools must be incredibly accurate so that when the monocell slides into place, the pre-bonded component can rotate directly onto it. A technician now transfers the completed assembly onto a dolly and wheels it to the next station. Here at Body Assembly Station 90, technicians bring the final body panels to a fixture equipped with an air vac system which suctions the parts in place. Once a technician slides the monocell into the station, it's clamped securely in place. Technicians then manually rotate the preloaded parts onto it. An automated ceramic heater system will cure the adhesive in just 35 minutes. A motor-powered mechanical gate rotates the roof panel 180 degrees onto the top of the car body. Thanks to that ceramic heater, technicians can unclamp the fully cured body panels after just 35 minutes. In the controlled environment of geometric and surface validation, a coordinate measuring machine, or CCM, goes to work. The CCM has 2 automated arms that travel the length of the body, measuring every element of the assembly. Extending from the end of each arm is a smaller arm that can rotate 360 degrees. This rotation allows the arm to accurately gauge the entire surface area. Precision probes mounted with a ruby at the tips of the smaller arms touch the car body at 304 different surface and geometric points. The probes record each position and compare it to the design specifications. Next, painters spray each car body by hand. McLaren works with Axo Nobel to formulate paint colors using a water-based system that reduces solvent emissions. In this case, the painters are applying the heritage McLaren orange. Bruce McLaren himself chose this paint for his early race cars. A clever businessman, McLaren knew that this color would set his race team apart. He had noticed that even on the black and white TV screens of the 1960s, orange showed up as a different shade of gray. There are 30 different stations in the paint process. Once coated, a car body moves through an oven. The oven bakes the paint at a low temperature to cure it. Then technicians polish the surfaces before inspectors examine the paint for any flaws. McLaren developed the award-winning M838T engine for its new line of supercars. Ricardo, another UK-based technology company, assembles this 8-cylinder powerhouse, which features twin turbochargers. Ricardo assembles the engines at this facility in Shoreham, UK. The engine moves through 10 different stations during the manufacturing process. At this station, a technician applies a lubricant to the 8 pistons before installing them in the aluminum engine block. A guide placed over the cylinder openings helps him with the installation. Once the technician finishes installing the pistons, he rotates the engine to gain access to the bottom of the connecting rods, or con rods. He adds bearings and attaches the pistons to the crankshaft. A testament to McLaren's commitment to handcrafted precision, the bearings are individually sized for each con rod. When turning, the crankshaft will churn out 616 horsepower, with the engine displacing just 3.8 liters. Once the pistons have been fully installed, a computer numerical controlled machine, or CNC, applies bonding adhesive to the top section of the block. Despite its power, the engine is surprisingly compact and lightweight. A set of guide rods helps the technician locate the part on the block. The technician further strengthens the block with bolts. Next, a worker positions the cylinder heads on top. The 2 cylinder heads have double overhead camshafts. Technicians use precision tools to tighten each of the bolts to achieve optimum clamp load. A worker fits the drivetrains to the front of the engine. These will drive the 4 camshafts and engine ancillaries. McLaren and Ricardo have worked together to optimize every detail of the M838T engine. Their work has been recognized with the prestigious Engine of the Year award for 2 years running in the 3 to 4 liter category. Despite a power output of 616 horsepower at 7,500 RPMs, the engine has the lowest CO2 emissions in its class. The technician has installed all of the components, but before he can test that the engine will turn over correctly, he must ensure that he has applied the correct level of tension. He now fits the spark plugs to the 8 cylinders. The engine designers found weight-saving possibilities in every corner of the assembly. Even the walls of the spark plug tubes have been thinned, reducing their weight by 5.5 pounds. With everything in place, the front cover and cylinder head covers are installed, completing this stage of the engine assembly. Here at Station 8, technicians fit the exhaust manifold and twin turbos together with the required coolant and lubrication pipes. There are some tricky elements to the installation process. Despite this, workers must keep pace with the production speed. Specialized tools help them quickly tighten bolts to the correct torque at difficult angles. The lightweight intake manifold is one of the last parts to be fitted. Next, the technician installs the fuel rail. The engine's fuel consumption is 24 miles per gallon. This is extremely efficient for a V8 supercar. The fully built engines are transferred from the production line to specially designed pallets. From here, technicians prepare them to be fitted onto a dynamometer, or dyno. This test is known as BIPO, which stands for break in and pass off. Ricardo tests every engine to ensure it meets all of its parameters. Operators rev the engine right up to the limiter, and in some cases bring it to full power. During these tests, the exhaust system heats up to over 1,700 degrees. Once Ricardo technicians fully assemble the engines, they send them here to the McLaren Production Center in Surrey, England. These painted car bodies are ready to meet their brand new state-of-the-art powertrains. At the start of the general assembly line, a technician brings the powertrain over to a car body. He positions the powertrain directly under the body. The body will then be lowered onto the powertrain. At a different sub-assembly station, technicians have already united the engine with its 7-speed dual-clutch gearbox. Wheel-mounted rocker paddles allow drivers to shift the transmission between fully automatic, semi-automatic, and fully manual modes. A technician fits a heat shield over the engine before installing the exhaust system. He uses a battery-powered wrench to secure the components temporarily. He completes the process with a preset manual torque wrench. The exhaust system has been designed to optimize both efficiency and sound quality. A carbon ceramic braking system comes standard on the 650S. In the 1970s, the aerospace industry pioneered the manufacturing of this complex, high-performance material. By the 1980s, it began appearing on race cars. Not only is it lighter than metal, it's more durable, resists corrosion better, and can outperform traditional brake discs in both wet and dry conditions. At this station, a technician prepares the car for an operation called the engine run-up. He plugs an exhaust extraction system into a vent hidden in the floor. This way, when the vehicle is started for the first time, exhaust gases are vented out of the building. The vehicle has passed the engine run-up phase. It's time to install the engine cover. This includes another heat shield, creating a sandwich layer. The added layer quickly reduces exhaust gas temperatures from over 1,600 degrees to just under 600. A pre-fitted protective covering prevents damage to the paintwork during installation. The technician can now fit the air brake onto its mechanism. The air brake increases braking performance. It also adds drag and rear downforce. Two technicians move the car's lightweight windshield onto its frame, where adhesive bonds it in place. McLaren has maximized the depth of the windshield to enhance visibility for the driver. McLaren's signature dihedral doors first appeared on the legendary F1. With just a single hinge for an attachment point, the door system is eye-catching. At the same time, it's practical, straightforward, and lighter than conventional doors. After carefully fitting the door and ensuring all measurements meet the exacting parameters specified by the designers and engineers, the technician wipes down the surface. The general assembly line for the 650S features 34 stations. Vehicles move from station to station every 48 minutes, completing the line in roughly 27 hours. McLaren builds both the 650S coupe and convertible on this line simultaneously. This McLaren 650S is assembled. Now it's time for tuning and testing. In the wheel alignment and geometry area, technicians check all key cambers and alignments before preparing the car for dynamic testing. Wheel alignment is crucial for safe and efficient performance. McLaren uses a hub-mounted wireless wheel alignment system that deploys multiple cameras to accurately determine the exact position of the wheels. Technicians manually adjust the alignment to ensure it meets the exact design requirements. The wheels are custom-made from a lightweight forged alloy specifically for the 650S. Pirelli, a McLaren technology partner, custom-developed the P0 Corsa tires for the 650S. Once the wheels have been accurately aligned, technicians remove the wireless system. Then, each car is subjected to a final diagnostic test. This includes cycling the air brake through its range of motion. To displace weight and check the suspension system, every vehicle must travel over the dynamic displacement zone. This glass cube houses the dynamic testing equipment. Here, the car is run on a rolling road. A driver puts it through a rigorous testing program. A computer monitor in front of the car details the testing steps and registers the results. Most of the major components of the car have already undergone extensive testing. The engine alone goes through 5,000 hours of basic testing, followed by 3,000 hours of track simulation. Once the test is complete, the driver exits the dynamic test and heads for the next station. Next, the car enters an extreme wet weather testing chamber. McLaren calls this the monsoon test. True to its name, the facility releases a torrent of rain on the car. Over 4,000 gallons of water hammers the surface of the 650S from every direction. True to McLaren's efficiency goals, every gallon is recycled and deionized. Every model built at the McLaren Production Center must endure an extensive road test. McLaren calls this a shakedown. To prepare this 650S for its shakedown, the technician applies protection over the car's lower bodywork. This operation must be done both quickly and accurately to prevent the carefully prepared car from being damaged during the road test. Each 650S goes through the dynamic testing phase with the final alloy wheels and tires that it will be wearing when the customer first drives it. But for the shakedown, the technician temporarily replaces them with an identical set that has been put aside for this purpose. Now, a McLaren technician takes the 650S outdoors for the first time. He tests every element of the car's performance. An extensive test on road and track is required, working through the various systems, both internally and externally. This is a standard procedure in high-performance car manufacturing. It follows an engineering concept known as the bathtub curve. According to this concept, any components that might fail will fail early. So what survives the shakedown will last a long time. On a graph, this concept shows up as a curve that looks like a bathtub, hence the name. This car has passed the shakedown test and has finally earned its McLaren badge. This iconic symbol was inspired by the one on the hood of the legendary F1. The 650S logo completes the exterior styling. It's time for the last phase of production and one final quality check. Inspection lighting reveals any potential damage done during the shakedown. It's here that each car receives a final polish before it's handed over to the dispatch team for delivery. The shape of the LED headlamps, the distinctive door blades, and front and rear bumper design all contribute to the dramatic look of the 650S. As standard, McLaren trims the 650S interior with lightweight Alcantara upholstery. The electrically retractable hardtop roof automatically lowers in just 17 seconds. This can be done at rest or at any speed up to 20 miles per hour. Bruce McLaren dreamed of launching a road-legal sports car, but sadly, he died in 1970 while testing his latest Can-Am racer. The release of the celebrated F1 in 1992 fulfilled his dream. The 650S is the most recent addition to a range of McLaren supercars that speed Bruce McLaren's legacy into the 21st century.